All right. Good morning, everybody. And welcome to All Things Open 2021. Obviously, I'm sorry I can't be there in person with you, but for those who are on site, I hope you're able to enjoy Raleigh this week. I know the city has changed a lot in the last few decades. Personally, I recall my first visit in 2005, and the awesome walkable restaurants and bar scene in downtown Raleigh wasn't really a thing. So I hope you're able to get out and enjoy. And again, sorry I can't be there with you. Now, as most of you know, our headquarters is in Raleigh. And just like the city, a lot has changed at Red Hat since our founding in 1993. And certainly, a lot has changed with open source since then as well. To kick off the All Things Open event, I'm going to spend a few minutes discussing the current state of enterprise open source, what I see as important trends and topics that impact all of us. Now, you might remember 10 years ago, back in 2011, Marc Andreessen famously proclaimed that software is eating the world. Andreessen wanted everyone to know that software companies were poised to take over major pieces of the economy, and that industries far and wide were going to be disrupted by Silicon Valley software companies. Several years ago, it became clear to me that it's really open source software that's eating the world. Now, did you know that almost 99% of audited code bases contain some amount of open source code today? That's according to the State of Application Security 2021 Forrester report. And research we did this year with Illuminos, a market research firm, found that 90% of IT leaders said that they're using enterprise open source technologies. And this is astounding to me, because when I started at Red Hat nearly 16 years ago, we had about 1,000 people. And to think that we started so small, and today open source is so predominant across organizations and industries, it's truly humbling. And to now be able to say that we're a global company helping people transition to open source at a scale that, when compared with the early days, I never thought possible, it just floors me. Red Hat has about 18,000 employees in more than 40 countries. And we're proud to say that more than 90% of the Fortune 500 use Red Hat products and solutions. So that is a pretty strong data point that open source software really is eating the world. A shining star of the open source community today has been Kubernetes, which you can see in its massive impact inside enterprises. In response to our 2021 survey, IT leaders told us that Kubernetes is important to their cloud application strategies, and they're going to increase its use over the next year. Just look at the velocity of change and speed of development in the Kubernetes upstream. We've got about 1.7 million lines of code, nearly 4,000 committers, and more than one change every hour, every day. Over 3 years, nearly 70% of the code has changed. And it's almost unbelievable to think that more than half of the entire project has changed in just the last year. So all that velocity with Kubernetes is a proxy for its growing importance in the industry. I like to say that Kubernetes is to cloud as IP was to networking and Linux is to the OS. In other words, an abstraction layer that truly enables innovation above and below, enabling what Vint Cerf calls permissionless innovation. Kubernetes provides container orchestration on top of an infrastructure abstraction whether you're using bare metal, VMs, on-premises systems, or public cloud. And that infrastructure world continues to evolve, whether it's new hardware or cloud infrastructure services. It's also the foundation for higher level abstractions, such as applications, functions, and services. A lot of community activity swirls around that nucleus of Kubernetes. And applications, be it in-house development or ISV applications, are evolving rapidly, taking advantage of that cube layer below. Kubernetes has emerged as a focal point for the industry. And I would go so far as to say the de facto standard for cloud innovation. Another big trend in open source is edge computing. Edge computing is the ability to generate insights from data and act on these locally where it matters. Since the computing takes place at or near the physical location of either the user or the source of data, it results in lower latency and saves bandwidth. To me, edge computing offers the ability to give life to the transformative use cases that businesses are dreaming up today and bring real-time decision-making to last-mile locales. These can include like a far-flung factory with automated manufacturing, or a train roaring down the tracks giving off terabytes of data, someone's connected home with computing that provides both comfort and security, or an automobile speeding along the highway using automated driving features. Or even in space. Who thought we'd be running Kubernetes in space? But we are on the International Space Station. And of course, you know that Linux is on Mars. Maybe we can now say that open source software is eating the universe? All right. I'm being a bit grandiose, but back here on Earth, edge computing is definitely garnering a lot of attention. But with the opportunities that edge computing brings, there are also complexities that need to be taken into consideration as you build out an infrastructure to support these use cases. The first is the challenge of distributed scale. Edge deployments, which can range from hundreds to hundreds of thousands of nodes and clusters, need to be managed in locations where there may be minimal to no IT staff and differing forms of connectivity, some reliable, some intermittent. So there needs to be a centralized way to deploy and manage both the infrastructure and applications, and to wait for distributed nodes to tolerate being disconnected. Second, we know it takes an ecosystem of collaborators to build an entire edge stack, which means that developers to target that edge requires some level of commonality that we get from platforms like Linux and Kubernetes. And the third main challenge is around the variability encountered at edge locations. In a central data center, you pretty much have control and know the environment you are operating in. At the edge, sites can vary in size, network connectivity back to the central data center, power and cooling, environmental exposure, and even public access to the edge nodes, raising real security concerns. So you need a solution that provides a flexible set of options to meet the needs of different locations. At Red Hat, we're extending our open hybrid cloud strategy to the edge. Edge computing does not exist without the hybrid cloud. We believe an essential element of your technology story is a single horizontal open hybrid cloud platform. It's the platform that allows you to connect the core to wherever your workloads need to go on the edge, both for today and tomorrow. A platform that can handle any workload, any footprint at any location. In fact, I believe the rise of edge computing will soon challenge cloud computing for the footprint where most computing happens. A really cool edge use case that's not new in itself, but represents where Red Hat is heading, is bringing Linux into automobiles. This use case is exciting and also brings with it a lot of challenges, including the space and power constraints, or a specialized form factor and the ruggedized requirements. and specifically crucial safety and security concerns. Not to mention the data involved. Two automotive consortiums say that the average connected vehicle will produce up to 30 terabytes of data in a single day of driving. And that's their low estimate. So the more we keep moving computing and open source software farther and farther out to the edge, from automated manufacturing to automobiles and 18-wheelers to everything aerospace, the level of complexity will rise and the margin for error will shrink. At this point, I want to mention the hardware evolution that's having a big impact on open source. We're going to need to ensure that our hardware can deliver accelerators to help create better performance for specific applications, including edge use cases. And you see hardware is innovating at a pace that's staggering. It's got to keep up in order to support the different types of workloads, the demands for new capabilities, and address the constraints, like I mentioned earlier, for the automotive edge use cases, which is just one example. So yes, with the edge, there are challenges, but there's no doubt in my mind that edge's promise will continue to propel it forward. Let's talk about data a little more and where AI comes into the picture. Of course, we all know about the criticality of data, and it's only going to grow as we move forward, both in its importance and its size. According to the Linux Foundation, 175 zettabytes of data will be generated by 2025, which is 10 times more than in 2016. To me, data is the central actor in any conversation about the future, whether collecting and curating data to build more powerful insights, create new products, or better serve your customer base. And the combination of data and AI are going to be infused into every aspect of computing. From recommendations for developers, how they write and pull code, to implement it, like internal implementation details, to computer vision and intelligence. The list just goes on and on. In short, AI is going to be pervasive for the next generation of every single thing we're going to build. It's not just the software. It's software connected with data in motion and processed, persisted. That will be the future. So we could probably update our open source software is eating the world mantra to say AI is eating software. These systems are going to be complex, and automation is going to be key to managing that complexity. But at a certain scale, a massive scale with tremendous complexities, intelligent automation is required. It's a term I like to use. It's where intelligence is infused into operations and the developer pipeline, providing dynamic analysis of code and intelligence around the stacks you combine, for instance. This is an exciting area for the open source community because it's our future. When it comes to open source trends, we have to talk about security. This year, there's been a wave of attacks on companies, as well as a very important executive order from the US president on cybersecurity. The truth is, the attacks are not going to stop, and open source is right in the middle of the action. In 2021, there was a 650% year-over-year increase in software supply chain attacks aimed at exploiting weaknesses in upstream open source ecosystems, according to this year's State of the Software Supply Chain report. A question we're grappling with, as noted by Luke Hines, a fellow Red Hatter who's working on supply chain security, is how do you secure a supply chain for a product that has no physical form, no box to lock, and is created in an environment where anyone can contribute to it? This is the practical reality of open source that's at odds with knowing exactly where all your code is coming from. The threat landscape continues to change, and we have to keep up. Sigstore is a recent example of open source community activity that helps us address software supply chain concerns. It offers a method to enhance security for software supply chains in an open, transparent, and accessible manner. Sigstore is intended to make cryptographic signing easier and available to all at no cost. So far, the community counts more than 675 commits, 465 members, 20 organizations, and it's growing. But there's more happening in this space. Just last week, for instance, the Linux Foundation announced reinvigorated efforts in OpenSSF to secure software supply chains with new membership and commitment to collaboration in this really critical area. And lastly, I'd point out that in our experience with Red Hat Enterprise Linux, we were able to address trust and security concerns with our customer base. So 95% of the Fortune 500 felt comfortable with Linux. This is not, however, a mission accomplished moment. Our collective work on security remains crucial as the open source community continues to create new software that will change the world. To close, I'd like to talk about Operate First, community work that we initiated and are growing with the aim to develop and deliver open source cloud operations at scale. We all know that the mantra of upstream first is fundamental in creating sustainable community software projects. Operate First is a variation on that theme, bringing open source community innovation to the operationalization of software. The cloud has clearly demonstrated that software has latent value that is really realized when operated. Therefore, the layer used for the operationalization of software also has real value. In fact, that layer, which itself is actually software, contains important knowledge and value of how to operate, period, and how to operate at scale. When delivered as a proprietary layer, however, we lose the ability for communities to share their knowledge of operations, learn from each other, and evolve the operationalization of software along with that core software itself. So open source has to evolve to include the cloud-like operationalization of software. Now, that's the goal of Operate First, to ensure that the community is included in the operationalization of open source software. The way we're doing that is leveraging a community cloud we've initiated with others at Massachusetts Open Cloud. And Operate First cannot be successful if we don't get communities involved. So come join us and check out what we're working on. All of that is the spirit of an open approach, which has brought us here today. It's that same open approach that will help us explore the edge, changes in hardware, data and AI, open source security, and even operating open source code here on Earth, in space, and to infinity and beyond. So with that, I wish you a great All Things Open. Thank you.